Hello, fellow solvers. This is Cog with Cog Analytics, and today we are looking at 5 plus a bonus design patterns in Alteryx. Now, a design pattern in our context is a small collection of tools that, when connected properly, enables the user to solve a common problem in ways that individual tools could not. To get a better understanding of that, we will immediately dive into our first design pattern, which allows us to create a fixed output schema. So, to set up the problem, let's say we have an input file or input data that has the following structure: customer ID, age, and planet. And this is subject to change based on each run. But this is not the desired output format that we would like to see. Instead, we have a required columns file, which is a empty YXDB that has exactly the fields that we want in our output. In order to achieve this specific format, we can use two union tools back to back. Now, the first union tool will take as inputs the required column dataset as well as our default input. And when we do so, we're going to output all fields we can ignore and continue processing records so we keep the messages section of the results pane clean because we're trying to manipulate the columns, so we don't want to see a bunch of warnings, and auto-config by name, which is standard. When we do this, the output of the first union tool is going to be a superset of all columns involved. So you can see here we have customer ID, age, planet, and now name and email from the required columns dataset. The magic of this specific design pattern comes from the second union tool, where now we output a common subset of fields, and that common subset of fields is between the superset, which is the output of the first union tool, as well as the output of the required columns file. And when we do this, what you can see is that all we have left in our output is those desired fields from the required columns YXDB. So we have customer ID, age, name, and email, and those are outputted in exactly the right order that we expected. Moving on to our second design pattern. In this case, our problem, you can see our input here. We have customer ID and age, but we have a duplication of the data. Now let's say that we trust all unique records are good to go. We'll pass them through and continue on in the workflow, but we want to separate off the duplication so that we can see, perform analysis, clean up any unnecessary records, and make sure that our data is the way that we want it to be. In order to accomplish this, we can use a summarize tool to group by the key fields. In this case, we just have one key field, which is customer ID, and then we want to get a count on it. Once we've done that, we can see any records that have a duplication will have a count greater than 1. You can see here the output from the true output anchor, or the T output anchor, is only that customer ID that has a duplication. We can join that back into our original data set using the join tool, and now if we take a look at the L output anchor, you can see that all we have outputted is the customer ID and age of those records which are entirely unique. As an added benefit for this particular design pattern, the J output anchor gives you all records that have the duplicated records. And one of the extra bonus things you can do, or it's important to do to get this to work as expected, would be to deselect all write fields. And you can do that going to Options, Select, Deselect All Write. And this way you ensure that your output from the join tool is exactly the same as the input structure for you to process. Our bonus design pattern is the exact same design pattern, but with a small extension, and that's aggregated filtering. In this case, we have, for example, a data set. In this case, we pulled off of Kaggle of students' performance on testing, math, reading, and writing, and broken up by school and by student. Now, let's say we want to analyze these schools, or we want to analyze and see what behaviors or patterns exist in the students for schools that have performed well on average. In order to do this, we need to perform aggregated filtering. To do that, we can do exactly as before. We summarize where we group by the key fields, or field, in this case, just school ID, and then we perform all of our aggregation steps. So we want to average the math, reading, and writing scores. Now we can add a filter tool to the end of that so that we can only isolate those schools that have an average math, reading, and writing score over 70%. Once we've done this, again, we can join back into our original data set, deselect all write fields, and what we are left with is all records, so all students' performances, but only for those schools that meet this filter criteria. So in this case, All of the students here are from schools whose average math, reading, and writing score are over 70%. Continuing along, we have the crosstab, or in this case, a clean crosstab. This is something, thankfully, that's been fixed in version 2024.2. So if you are using that version and onward, you will no longer need this design pattern, but it's still something that's useful to know just in general, but especially if you're using an older version of Alteryx still, this will be helpful for you. So the problem with the crosstab tool, whenever you have an input, in this case we have our field names as well as the values, in this case customer ID and age are the field names we expect. When we perform crosstab, what you'll notice is that an underscore gets inserted in the place of our space. And so therein lies the problem. The crosstab tool replaces all non-alphanumeric characters, hyphens, spaces, asterisk, the number, the pound symbol, and a whole host of others with an underscore. Now this is not desirable because we had the exact output we wanted, the field name that we decided was in our input for the tool. And that got removed after the tool. So in order to solve this, or remedy this problem, what we can do is use a handy design pattern whereby we use the tile tool to index all of the column names. And to do that, we can group or use the unique value tile method on the column, which is the field name. And so you can see here, age is now associated with the number 1, and customer ID is indexed as 2. Now when we cross-tab, instead of using the field names that we have assigned, we'll use the tile number instead. And so you can see here we have 1 and 2, which are purely numeric characters that will not be substituted for underscores. The added benefit of doing this replace is that because the crosstab tool sorts your columns, you can separately sort the data so that the tiling keeps the order that you desire for the output. That's an extra step. Right now, we're just focusing on keeping the field names the way that we want them to be. And so in order to do that, you can use the summarize tool to create a mapping from the tile number to the expected or the original field name. So you can see here again, the 1 goes to age and 2 to customer ID. And now we can use the dynamic rename tool from the developer palette to rename those numbered field names to the original field names that we expected. And so you can see here that by the end of the process, what we have is our crosstab data, except the field names are exactly as we expected without the underscore. Moving right along, our next design pattern is the top N by category. In this case, we have data again pulled from Kaggle that has films, their year that they were released, as well as their rating and various information on genre and budgets. Now, for our purposes, let's just say we want to study the highest average rated films, and we want to take a look at how that compares against their budget for a given year. So in order to do this, the first thing we need to do is sort the data by whatever key metrics that we are tracking, in this case, the voting average, or the average vote, rating, and descending order. Next, we will use the sample tool, sampling the first, in this case, 5 rows by year released, group by year released. And what this will do is it will pull the top 5 records which have been sorted by the voting range. And so what you can see is that what we're left with, I will expand the results pane, is for each year we have the top 5 rated films, and now we have their budgets associated that we can then perform our analysis on. Again, very useful, very simple design pattern. Moving on to our last design pattern, and that is what I have termed subset aggregation. So let's say in our example dataset, we have products, their color, the date of the transaction, and quantity transacted. But when we want to aggregate this data, we don't always just want the total of all the data that we have. We may want to know how many red products we have sold, or we may want to know month-to-date calculation for how we're performing this month, or a year-to-date calculation, for example. And all of that can be done with subset aggregation. So in order to do that, first you need the formula tool. And what you'll do is you will utilize the criteria that was specified within an if statement. You'll create a new column, in this case, let's just say red quantity, and then we can check to see if the color is equal to red, then we want the quantity, otherwise use 0. And what this is doing is it's getting rid of all the extraneous data that don't meet this criteria, so that when we run our aggregation, we can ignore these specific records. Similarly, for month to date, you can check to see if the month of the transaction date is equal to the month of our current month, in which case we want to keep the quantity, otherwise set it to 0 again. Now we can do our aggregation, grouping by the product, and now we can sum up the red quantity, month to date, and as well we can look at total quantity, and we can see each subset and how it performs against the total aggregate of all the input data. And so you can see here we have cabinets, chairs, tables, recliners, and rockers. We can see how many are red that we've had transactions for, what our month to date totals are, as well as our total quantity for the entire data set. That is all of the design patterns we're covering today. Please like, subscribe, and comment if you have any design patterns that you've used that you've found valuable. I am very excited to make more of these and would love to showcase some other other solvers, ideas, and design patterns. So please comment, share anything that's been useful for you. Again, if you have any questions, also put that in the comments. Love to help. Check out the Alteryx community discussion board. There are plenty of expert users there that are always happy to help solve your problems. Anyways, as always, hope this helps and happy solving.